Let's get acquainted with the functionality and capabilities of the ABM Rinkai TMS system. To do this, let's build the test routes and then analyze their implementation. First, you need to download all your orders. Applications can be uploaded to the system using CSV files, web service, or Excel. In our case, applications are already automatically uploaded to Rinkai from the accounting system with the help of API integration. Each application has a number, date, name of the client, weight, and a third parameter. In this case, this is the quantity of pallets. This is for orders moving from warehouse to customer. It is also possible to take into account orders that move in the opposite direction, which we call returns. Return weight and return third parameter are indicated for them. One order can contain both parts as well, or they can be downloaded separately. Consequently, according to orders, we have a time window, which is characterized by either a whole range, as in this example from 6 to 8 a.m., or a range which consists of two time windows in the case if the client has lunchtime, for instance. Suppose that there is a break from 14 to 14:30. Visually, we see that the windows are different. It's like a Gantt chart. It shows how many different windows are taken into account, and the system is obliged to take this into account as a limitation while planning. For each order, the time required for loading a given volume and weight in the warehouse, as well as unloading at the client, is automatically calculated. The larger the weight and size characteristics of the order, the more time the system takes as administrative time. All estimations depend on the entered statistics. Let's take a look into a tab of vehicles that will deliver orders. By editing one vehicle, we can see all parameters that are taken into account, while the system chooses the cheapest vehicle to deliver your orders. In the basic parameter, we can see a code and state number. Code is necessary for synchronization with the accounting system so that it also understands what kind of car it is. You can select a career directory. In this case, two are entered, but there might be more. Note that this car belongs to the own fleet. Select a driver from the directory. You can also set the GPS data source for the car, from where we will receive actual data on how the car completed the route. This can be our RouteSense app, or it could be a stationary tracking system like stationary GPS trackers or those that plug into the cigarette lighter. Also, you can see here the vehicle's availability parameters, that is, available or unavailable, from what time and until what time we can use this car. In addition, there are various parameters characterizing which list of roads this car can drive. There are different car profiles: light, medium, heavy. In this case, the car belongs to the medium group. This determines the roads that are available to it, taking into account the weight and the size characteristics and restrictions on the map. So the vehicle will not go where it cannot pass according to the road signs. Then there is the gross weight of the car, that is the total curb weight, the carrying capacity itself, the volume, and various limitations for loading the car by weight, volume, and the third parameter. Let's say we want to let the system know that loading a vehicle by 110% is fine. The system will use this information as a gap to load this car more than others, if necessary. Let's move on to another parameter such as time availability. In the ABM Rinkai TMS system, it is possible to limit or set breaks in the use of the vehicle driving and also set certain speed indicators for the speed of movement, depot loading and customer unloading time, which are specific to the particular vehicle. Therefore, for this, the current tab with the settings is used. One of the main tabs on the profile of the vehicle is the costs for each car. This is the cost matrix associated with the use of this car. For instance, there is a daily expense, a mileage cost, and an hourly charge for each driver. Summarizing these indicators according to the parameters of the route, we can calculate the total cost of all logistic expenses. Moreover, the system takes into account all entered parameters at the same time. It can also be cost for a visit to a point, cost for delivery of one unit of weight, volume, possibly some third parameter. Similarly, the opportunity cost of weight, volume, and third parameter of return orders. Depending on how the cost matrix is configured for each car, the system with the same parameters of load capacity, etc., chooses the cheapest vehicle to deliver all your chosen orders. The last but not least parameter of the vehicle is the driver's contact information. This includes contact information, which can then be transmitted to customers in messages indicating the contact details of the driver, of the car, and so on. In particular, it may be taken into account that the car doesn't start from the warehouse, but starts from a certain site, visits or doesn't visit the warehouse before going on the road. Similarly, returning to the parking lot with a visit or not visiting the warehouse before parking. We have delivery points that are characterized by a code. We synchronize with the accounting system the client's name, address, geo-coordinates, standard time window, as well as waiting time, if this is expected. Also, it is necessary to take into account the capabilities of the depots. This is the productivity schedule that the warehouse can provide us with over a period of time. Simply, it just shows what is the maximum number of cars that can be loaded or unloaded at the same time. In this example, we see that the warehouse works from 12 a.m. to 10:30 a.m., from 12 a.m. to 4:30 a.m. 3 vehicles can be loaded in the depot at the same time. This is a specified maximum. Then the productivity decreases to 2 vehicles. An important task is to take into account specifically this decrease in productivity and not to plan more routes during this period than the warehouse can release. And finally, we are moving on to the magic of planning. To begin with, we need to select all orders and press the Apply button. We get to the Planning tab. The interface of the planning window contains the following objects. This is a map with delivery points on it. The list of vehicles available for planning with different load capacities and volumes. Schedule of composition capabilities. A list of unplanned stops. Click Optimize. The system begins to select a list of routes, a combination of delivery points, which on the one hand ensures that we comply with all previously introduced restrictions, and on the other hand shows the amount of costs required for the delivery of orders with the available resources in the form of transport. All costs are taken into account that correspond to this machine, and as soon as the system finds a more profitable solution from the point of view of saving money, we immediately see a decrease in the total cost of logistic expenses. For each of the routes, we see the selected vehicle, the total number of stops, the start and end time of the route, the time of use of the given car, as well as the driving time that the driver must spend. Below, we can see the sequence of points that must be visited in order to deliver all orders within this route. As you can see, for each delivery point, the time of arrival at it, the duration of unloading is taken into account, and the time of departure is also known. Visually, here we see time windows and a red line which visualizes the time at which the car will be in the delivery point. The wider this red line is, the more time the car spends at the delivery point. In this example, we see that when shipping an order weighing 21 kilograms, the vehicle spends about 6 minutes at the client's location. We can see the same route on the map. You should just click View. As you can see, now we can visually see the roads along which the delivery is carried out within the framework of this route and the sequence. Routes can be switched and viewed without returning to the main interface. At the same time, as part of the route and road construction, the system takes into account the road network, the speed map, which is collected from the statistical data. The faster this road is, the more likely it is that the system will route along it. Also, ABM Rinkai takes into account the restrictions placed on the map. For example, in this case, we can see how many restrictions are used. These include weight restrictions, road closures for certain types of transport, maneuver closures, and so on. That is a very large list of cartographic data that must be taken into account when building a route. So the warehouse capacity is filled behind the cars. On the Gantt chart, we can see how many routes are expected for each vehicle, when they start, when they end. The map is interactive, and we can go to one or another route we are interested in by double-clicking. Also, the system has filled the productivity of the warehouse and their disposal. That is, we have red areas that visualize how many cars will be loaded in the warehouse at a particular moment in time. Here, it's necessary to pay attention to the fact that the schedule of possibilities is exactly followed as we said. That is, when the warehouse has resources, the system plans a car for loading. When there are no resources, the system doesn't put them there. After the routes are planned, we export them to the accounted system using the same CSV protocols or web service. In this case, we will use CSV. It is necessary to enter the name of the route plan, for example, tests, indicate the delivery date, in our case March 8, and click OK. As you can see, the route plan is saved, blocked, and it briefly reflects all those characteristics that correspond to it.